Hey, well, I think we are live, and hopefully this week goes a little bit better than the last time we were together. And tonight we get to talk about construction engineering, and I'm excited about this. We'll get to go through some of the different problems here. I mean, project administration, construction operations and methods, project controls, estimating and interpretation of drawings, and honestly, the first time I taught this course, the construction admin type course, it was like 6 to 8 on Tuesdays and Thursdays, and by Thursday, I think everybody was just like falling asleep. It can be kind of dry, but hopefully it gets a little bit of fun. I'll have a couple of it'll be a good project win kind of jokes at the end of real true life things that happened to me when I was in the real world building things. And but this should be good here, where we're gonna go through probably a lot of conceptual questions tonight. We'll talk through some of those. We'll talk about some alternative question format types as well, where I think these could show up in this. Well, they could show up anywhere, but I think it's a good fit for what we're doing here. And then, in addition, I think where we're going to go is we're gonna look at some of the estimating pieces and come up with some basic estimating, scheduling, some numerical pieces. So hopefully it'll be good. But let's just jump right in, and we'll get started. So if you haven't downloaded the latest questions, I did make a couple tweaks today, so you can check those out. You can pull them up. The latest version 1.1 should be there as well. So let's get started. This first one is probably one of those types of things that could show up as an alternative question type. Right, so here what we have is project delivery. And when the couple times I taught the project administration course, the first thing we jumped into is project delivery. How are these getting put out there? Where do they, who has the contract relationships? So that's where this is going. Shown below is a schematic diagram of a traditional design, bid, build, construction project organizational chart, right? So this says who's on top, who's on the bottom, who's calling the shots, and that sort of thing. The lines represent contractual relationships and place the relevant project parties into appropriate positions. So what we have here are a whole bunch of project parties. And what I did is, since I'm presenting this, I made some little, these little, let me get a pointer here, but little things that I can stick places, right? So the question is, who is at the top? Well, as much as I love engineers and I love to stick them at the top, don't write that in yet, because engineers aren't really at the top in this process. I mean, the engineers are the ones that are top in the safety realm of things, because the engineers are the ones that put their stamp on it to say that this thing's safe or unsafe. Okay, but really, the one that's at the top, the one that is paying the bills, is going to be this owner. So the owner is really at the top in the design, bid, build process, right? So they're the one that holds contracts with everybody. And who do they hold contracts with? Well, typically, this is where we get the engineer, and the engineer is going to be under the owner. Typically in a design, bid, build process, what's going to happen is the owner is going to come up with a contract. They're going to contract with the engineer to do a design. Okay, and that design can be for a building, could be for a roadway, could be for whatever. But the owner, the person that's in charge or owns the property, is going to contract the engineer to do that. Sometimes what will happen is the engineer will need help. Let's say it's a structural engineer and they need help on HVAC or fire protection or plumbing or electrical or something like that. The engineer is going to work with subconsultants. So oftentimes the owner has one contract with the engineer, right? So that's this contract here. The owner has one contract with the engineer, and then the engineer has some contracts with additional subconsultants, right? So this is the kind of the engineering side of it. What happens in the design, bid, build process is the design gets completely done. It gets vetted with the owner, and the owner's happy with it. And then from there, what's going to happen is the owner is going to go out to bid, or the engineer is going to take this project out to bid, and they're going to go talk to a whole bunch of contractors who are going to bid this project and come in with hopefully the least cost competitive price. And typically what you're looking for is the lowest cost, the lowest cost bidder that's qualified, right? So this is the person. Hopefully you're not throwing people out because of qualifications, but typically the next contract that's going to get let here is the one to the contractor. So the contractor is going to be the next one, right? And the owner has a direct relationship or direct contract with the contractor. Well, what's left over here? And this is on the FE, you're going to have some of these drag and drop formats, right? Where you have to be able to take the different pieces and drag them in. All right, what's left? The contractor is going to kind of contract with, well, subcontractors. That's kind of an obvious one, hopefully. They're going to hire, you know, whether if it's a general contractor hiring a site work contractor, a general contractor hiring an electrician, or whatever it is, the general contractor is going to sub out different pieces of the job. They're also going to work with fabricators who are going to produce or build certain components. So on a steel job, you're going to have a contractor, but they're going to contract with a steel fabricator to go, you know, build the steel pieces, and then it'll get erected on the site. In addition, the contractor is going to contract with suppliers who are going to supply the different materials and pieces and components that need to get built. So the contractor is going to have multiple you know, sub kind of contracts here with subcontractors, fabricators, suppliers. And the last one here, what do we have? We have an inspector testing agency, and honestly, this one can kind of get thrown into different places, but the way that the International Building Code is written right now is in Chapter 17 of that building code. It's a chapter on special inspections. And that requires that the owner directly contract with an inspector or testing agency. So there's no conflict of interest, right? If the owner has the contract directly with the inspector or the testing agency, we know that there's not going to be really a conflict, right? But like let's say for example, you put the inspector under the contractor. Well, that's a conflict of interest because now the contractor holds the payment for the inspector. So we don't want that scenario. There have been cases where I, as an engineer, have subcontracted kind of some of the testing inspection agency because they have our best interest in mind as well. There's less of a conflict there. Sometimes the owner will want to do that. But a design bid build process, typically this is going to be an org chart where you have the owner on top, you have the engineer as the first primary contract, the design gets done, it goes out to bid, and then you get a contractor on board to build it. Okay, so step one, kind of project delivery methods. This is kind of 101 for project administration. All right, so hopefully that one makes sense. Some of these questions are just going to be conceptual questions where we talk about things and I wave my hands in the air, but hopefully it builds up a base of knowledge in the construction industry. And some of this stuff hopefully is a little bit of common sense too, but hopefully it works for you. Okay, so let's go to question number 2. All right, so question number 2 here says, here's another alternative question type for the FE. So the FE can have multiple choice where you get 4 potential answers, and you pick one of them. But the FE can also, if you look at their alternative question types, can also have multiple answer. So here we have 6 types of, six boxes that we can check for this question. And the question says, various statements related to project delivery methods are provided below. Select all, so that means you have to check multiple boxes here. Select all that clearly demonstrate an advantage of what? Of design build over design bid build. So we just talked about that delivery method of design bid build, right? So design bid build has the owner on top, and then the primary contract to the engineer, right? And another primary contract, I shouldn't say secondary, another primary contract to the contractor, right? And so this is the one we just did. This is design, bid, build. Okay, so that's the one we just looked at. Well, what's the difference with design build? And this is becoming more popular, especially on some government projects. I've seen this becoming more popular here. But design build, what does this look like? Well, design build, it still has the owner on top. But instead of going out with two separate contracts and looking at, let's get an engineer and contractor, what it kind of does is it lumps those two together. So we get a design build or DB entity. And sometimes this is led by a contractor, sometimes it's led by an architect, sometimes it's a joint venture between the architect and engineer and the contractor. But underneath the design build entity, you have the AE, the architect, the engineer. You also have like your GC. So this becomes one entity, and then from that entity, everything gets done. So there are some advantages to that, and the first advantage that we're going to point out here is just this, right? There's a single point of contractual responsibility. So that's a good thing, right? In terms of what the owner has, the owner doesn't have to say, well, no, it's the engineer's fault, no, it's the contractor's fault, and then have people point fingers at each other. The engineer can just say, hey, I hired you to do this job, and there's a problem, go fix it, right? So the owner likes that in the sense that there's a single point of contractual responsibility, one payment, you're done, right? That's an advantage, okay? And let's keep going. There are contractual relationships with the owner that prevent a conflict of interest. Well, we get that conflict of interest thing going on again, right? And this is where I think the design build process is a lot better, or I'm sorry, the design bid build process is a lot better to avoid conflicts of interest, because the engineer is always working directly for the owner. In the design build version, right? In the design build version, especially if the GC is kind of like the prime or the lead on the design build entity, you can get the problem where the contractor's kind of pressuring the engineer to do something, or there's a financial incentive to the engineer to do something, you know, that maybe would be beneficial to do a different way. Maybe they're both safe, but maybe the one way is more beneficial to the engineer, so they're going to, you know, tend to go that way. So there are some, you know, advantages, disadvantages here, but I think the contractual relationship piece is a little less likely to prevent conflicts of interest with a design build option. Let's go to number 3 here. The design is clearly and explicitly defined at the outset of the project. Well, with design build, that does not happen. Design build, you basically start with, well, you start with some concept. And sorry, I should probably spell that correctly, but you start with like a concept design. You start with some programming requirements. We need a dorm, for example, that'll have 300 beds. Okay, well, how many are singles, how many are doubles? Well, maybe that isn't even defined yet, right? But we need 300 beds. So we have this concept, right? And then the design gets worked out. The concept goes into a design, which gets worked out into a build, you know, into a building or whatever is going to get built. But really where this all starts with design build, it's just kind of this concept of, here are the general programming requirements, but not the specific design that you would get in the design bid build. So in the design bid build, everything's done before you bring a contractor on board. Okay, so this is where design bid build, right? Design bid build, everything's clearly and explicitly defined at the outset of the project, or at least it's supposed to be. It doesn't always work that way, but it's supposed to be. Okay, whereas design build, you basically start with like a concept, a conceptual design, and you have to work from there and go from there. Okay, let's go to number 4 here. The design includes significant collaboration between the engineer and the contractor. Design bid build, there really isn't significant collaboration here, but design build, they're both on the same team. So if the architect or engineer is working on this and they're going through the preliminary design, they can go to their GC and say, hey, we're thinking about this method or this method, do you have a preference? And that's where the collaboration, maybe savings, can be achieved or realized for the owner. So that, I'd say, is an advantage of the design build. You have both of the general contractor and the architect engineer on board on the same team, and hopefully they're working for the same goal to help the owner. Okay, let's go to the next one, number 5 here. The schedule can be fast-tracked and construction can begin before the complete project design is finalized. Okay, design bid build, let's just start here again. Design bid build, design is done, then you go to construction. Design build, Well, what's to say that we can't start building as soon as the foundation drawings are done, right? The rest of the building might not be done, but why can't we start the foundation as soon as the foundation's done, right? As soon as that foundation design is done, we can hit the ground running, and we can still be designing the rest of it, you know. But here with the design build version, we don't have to stagger things, right? We don't have those dependencies where, like if we're thinking of Gantt charts, right? What do we have? We have, you know, design, bid, build, right? We have design, right? If we have Gantt charts here, we have a project dependency where we then go to bid, right? And then we go to build, right? So this is a, you know, finish to start dependency. Whereas with design build, these can start to overlap, right? So instead of having these, you know, these distinct and discrete pieces, right? We're doing the design and we're doing the build, but they don't have that same start to finish dependency, right? So this is where there's going to be some offset here, right? There's going to be some offset because you need a little bit of time for the first part of the design to be done. But if we're looking at like a Gantt chart, for example, and this is a very crude Gantt chart, by the way, but if you're looking at that, we don't have these, like, you know, this is like a finish to start dependency, or FS dependency, finish to start. Whereas this is more like a start to start, but an offset, right? This is like a start to start. This is more like a start to start with, you know, plus, you know, 1 month or whatever it takes to do that first part of the design. So you're going to have that little bit of offset, but it doesn't need to be completely offset. So I'd say that is an advantage of design build, right? You can actually start to fast track this thing. And let's go to the last one here. The owner will receive a project at the lowest competitive cost. With design, bid, build, right, you have the idea here that you have one project, you know what this project is, you canvass multiple contractors, and you get the lowest qualified price. Okay, design, build, or design, bid, build, that's what you're doing. You're getting the lowest qualified contractor to give, you know, their price. Design, build, you don't even know what the final design is, right? So how can you get the lowest competitive price if you don't even know what the final design is? What you're doing, again, is you're getting some concept out there, but you're not going to get the lowest competitive cost necessarily. You're going to get a cost where, yeah, they have to come in within a certain, you know, project range or cost range, but they're not gonna get the lowest competitive cost on a design build. Yeah, they might get some low rates potentially, where the owner will say, okay, we want your rates, your labor rates, your design rates. We want those rates, and we'll compare those rates to other firms or other entities. But those rates aren't the final project cost, right? And we all know that when you take your car to the mechanic, you want them to not do it in 2 hours. You want them to do it in 1. And it's not, you know, it's not necessarily that you don't have control over that exactly. In the same way in the design build option, you don't necessarily have control as an owner over exactly how many hours that gets spent on the project. There are some caps, there are some ways to cap it and put some cost controls out there, but you're not necessarily going to get the lowest competitive cost. So on a question like this, right, you have to kind of look through each of the answers. Oh, sorry, that should not be green. That's a red one. I put a red X. So on a question like this, you can't just like read until you get one good answer and then stop. Right here, you have to actually evaluate all of them, read all of them, and this is one of those alternative question types that could show up on the FE. So if you have questions, I am trying to monitor the chat up here as well. But you know, let's go from there. Lump sum versus time and materials. You can do both. You can do either. Typically, well, I shouldn't say typically design bid build. Design bid build can be either, especially on linear projects where you're doing a linear roadway. You can bid those out, even if it's the design's all done. You can bid that out ahead of time. With design build, you can also do some lump sum in terms of, hey, this is how much you have to. This is the maximum we're gonna pay you, right, for these program requirements. But then what happens? Well, maybe finishes get changed, or there are things that get changed because, or maybe they're not specified yet. So you can, you know, project pricing is different than the project delivery. So project pricing, I probably should have put more questions in this review on lump sum versus time and materials and that type of thing. But you can kind of do either. So whether it's a lump sum project or a unit cost project, that's more a little bit in terms of probably the nature of the project, because some of the linear projects where you have a bunch of excavation or a roadway or something like that, unit prices make a little bit more sense, where on a building where it's a defined unit, the lump sum kind of makes a little bit more sense. So that's more project type versus project project delivery. So hopefully that makes a little bit of sense here. Okay, but let's keep going to question 3. So question 3, indemnification clause. This was my favorite clause in when I was reviewing contracts. And indemnification, I threw this one out there in, I think, one of those videos earlier of how to pass the FE or something. But what is an indemnification, right? And I went and looked up a definition just to make sure that my understanding of indemnification was right when I said this. And what is the good world of Google tell us about what does indemnification tell us? Well, indemnification is to compensate for harm or loss. So let me just write that down. Indemnify, so to indemnify means to compensate, right, for harm or loss. So as an engineer, there's always going to be an indemnification clause kind of thrown in there, right? In any contract, there's going to be an indemnification clause. Not that we're expecting people to be harmed, but even if you look at those agreements that you see when you're scrolling through, like, you go to sign up for something, there's an agreement, and you agree to indemnify, whoever. Well, what you're doing is you're saying, I'm going to compensate you if there's harm or loss, okay? And that's where you have to be careful, because a lot of times, especially from the professional side of it, like the professional engineering services side of it, and you guys are taking the FE because you want to become PE someday, you have to be careful, because we would get contracts in, and they would say that we agree as the engineer to indemnify the owner and hold them harmless, right? And compensate them, right? Compensate them for harm or loss against any failures, against anything that happens, against any claims, which my boss would always take an exception to, and he would go up with the best of the lawyers, and he would just argue them and say, no, that's not insurable. We can't insure, like, our insurance company is not going to pay for claims that are unfounded. Sure, if we are negligent in our design, we should pay for that. So we designed something wrong, we made a mistake, we should compensate you for that harm or loss that's caused. But we can't just compensate you because somebody makes a claim against you. Does that make sense? See the difference? So that's where really indemnification starts with this. It needs to be tied to negligence, and that's where, if you talk to your professional liability insurer or whoever, negligence is really key in holding that and tying it so that it has some teeth and that it's enforceable. Because insurance companies don't just want to pay for claims, they want to pay for actual things that happen. Okay, and that's where I kind of threw the second one in there just to really throw it out. But claims, you got to be careful of that. Attorney's fees do get thrown in because those are actual losses. Project overruns, right? Overruns, typically indemnification's not for a cost overrun. And typically indemnification's not for, again, this is an engineer's design contract. Engineers can't be responsible for the improper construction methods of the contractor, right? Does that make sense? So if it's an engineer's design contract, they're not going to be held responsible for improper contractor methods. Okay, so that's where I think indemnification really needs to be tied to negligence. So there's a comment up there: understanding the design build takes a lot of the risk off the owner, places it on the contractor and the AE. In general, I mean, owners take on risk anytime they're building something, but the idea, what you're doing is, as an owner, you're trying to minimize risk by getting an engineer with a PE stamp that has the training and the exam and the backing of their state to actually go and design that project, right? So the owner's trying to limit their risk that way. The contractor's trying to limit their risk by working safely, hiring qualified people, right? But I think risk, and I think probably a better way of looking at this is kind of this first idea here, is in the sense of there's that single point of responsibility. So the owner can just say, something's not right, go fix it, design, build entity. So that's where it's, I don't know so much the risk. I think the risk is probably similar in some ways, but I think that single point, there's not going to be this infighting. It's, hey, this is wrong, go fix it. Okay, so I think that's a huge advantage of design build from that standpoint. Indemnification, the design build entity is going to have to indemnify the owner and hold them harmless against their failures for both the design and the construction, right? So that's going to be something that's going to be taken into account into that contract for sure. So when you start looking at contracts as you get into this, definitely take a look at that indemnification clause. Be wary if you see something about claims in there. You don't want to indemnify for claims. You want to basically take your responsibility and indemnify for negligent design. All right, let's keep going here. So a bunch of conceptual questions. We will get to some numbers later on, but collusion. Oh man. You got to watch out for collusion. So we'll hit on the mafia later on. So, but collusion on a construction project typically refers to which of the following. So these are all four things that are not good. Okay, but let's read through them. A practice where multiple contractors conspire to fix prices or rig bids. Right. So let's say you have 3 or 4 main contractors in an industry, and they say, well, okay, you 3 bid high on this project, I'll bid, not quite as high, but still high, I'll take this one. Next one I'll bow out on. Okay, the next one, the other, 3 of the other ones can bid high, and this one can take the project. And I'm not going to show you this one because that would just be, that would be wrong. But you get the picture, like there's this conspiracy where these contractors start to artificially inflate prices and all work together to get the prices higher, but still have a low bid in the sense that, there's one contractor that's been the chosen one to win the project and they all share the profits. So that's, bid rigging, fixing prices. A bad practice, an illegal practice, and let's just keep going. We'll come back to that in a second. So B, a system where public officials receive money from the contractor after the award. So this is called kickbacks. It's illegal. It's what got Spiro Agnew kicked out as vice president back when Nixon was in office. Okay, Spiro Agnew took kickbacks while he was in the White House from contractors. I mean, and eventually he got taken. We'll throw Al Capone in there on the the tax evasion crime, right? He didn't report those kickbacks on his taxes. Since then, kickbacks have become illegal. Obviously, we don't like to see our money go back to public officials for bids. That's a bad practice, not a good practice. But we're still looking. We're looking for what collusion is, and maybe you've already figured it out. But let's go to letter C. Falsely increasing the price of a change order. Does this happen? All the time. Okay, all the time. Is it illegal? Probably, but is it bad? Yeah, it's annoying. Okay, I remember there was one job I was on, and we were going to run a pipe one way, but the owner was supposed to get a right of way through the property. And what ended up happening was there was a lien on the property, and we had to move the pipe. So we moved it, and we actually had the same exact linear footage of pipe. The only difference was we had to tunnel under a road. I called a local contractor that did the tunneling, and the contractor said, okay, $5,000. It's not a super, it's a small pipe, nothing, $5,000. We got a change order, guess for how much? Not $10,000, not $20,000, not $40,000. We got a change order request for $80,000. I mean, 5 to 80 is just quite a lot, right? So we said, no, this is wrong. You maybe missed something, but maybe you should go talk to this other subcontractor who can do the work for you, because we talked to them, and $5,000 is probably more reasonable. And eventually the contractor we were working with came down. We were able to get an agreeable price and make it work. But does falsely increasing the price of a change order happen all the time? All the time. Was that a false? Did he falsify it? I don't know. Maybe it was just one of those ones where they wrote the an extra zero in there by accident. I don't know. I don't really care at this point, but it does happen. And then D here, misrepresenting the amount of work that has been completed to get advance payments. Does that happen? Oh yeah, all the time as well. Like, right? Because why do you want to get more money up front? Because then you have more money up front. Okay, you want, like, a lot of times your mobilization costs, the contractor, how much did you put in mobilization? As much as you can, right? Why? Because then you get as much that contract money up front just to start the job, right? Whether it's bringing a job trailer on the site or mobilizing your equipment to the site, you want to get that money up front as quickly as you can, right? So these are all things that happen on job sites, but what collusion is, and collusion typically refers to this practice of bid rigging, where the contractors collude together and conspire together to fix the prices. So I wanted to go through all of them, but the answer to this one, collusion, is typically a practice where multiple contractors conspire to fix prices or rig bids. This is fun, man. We got Al Capone in there. We got all sorts of things. So let's keep going. Okay, so project administration. We'll keep going on project administration. And one of the things you're going to do in project administration is you're going to hold a lot of meetings. So your life becomes a bunch of meetings where you're going to be going to meetings, you're holding meetings all over the time, all the time, to talk to people, to make sure everybody's on the same page, to coordinate things. And I've gone to a bunch of meetings in my life for different jobs, but specifically a pre-construction conference. So what's a pre-construction conference? It's a conference between parties before construction, right? Nothing too crazy. You're going to talk about site access. You're going to talk about working hours. You're going to talk about points of contact. You're going to talk about safety precautions. You're going to talk about, traffic schedules, different things along those lines, staging, some of those things, right? But when are you talking about these things? You're talking about it with the actual contractor that's going to do the work, right? So the pre-construction conference is really going to be the one that you do after you execute the agreement, but before you give a notice to proceed, right? That's when you want to do this. You want to have a contractor on board so you can talk specifics about, going over the construction documents, going over superintendents, who's the point of contact, all the basic stuff you need to run your job. But it's before you actually give the contractor that notice to proceed and say, okay, go ahead, get started, Mr. Contractor. And the thing with construction is different agencies have different processes, but typically prior to advertising for bids, you don't have a meeting because nobody knows the job exists. Okay, that's just a design meeting, right? This is more like a design meeting, right? What happens? Well, after you advertise for bids, this is typically known as the pre-bid meeting, right? So the pre-bid meeting is when all the bidders get to come to the site, get to ask questions, get to examine the actual conditions. After bid opening, but before award of the contract, you could have another meeting where you interview kind of the contractor and make sure we're all on the same page. But that's typically not a pre-construction conference. That's like a pre-award conference, just to make sure that everybody understood everything correctly. So maybe I could call that like a pre-award, conference. But there's a ton of meetings, a ton of conference calls. If you like being on the phone, that's something that you will do a lot of if you get into construction. Okay, let's keep going. We good? I think so. Project admin. Okay, project admin, we're still there. Types of submittals. What's a submittal? It's something that gets submitted. And my kids would yell at me like, you can't use the word in its definition. Okay, submittal is a piece of paper that gets sent in to the engineer that says, okay, you said you wanted PVC pipe that's SDR35. This is the pipe that we're going to use, the specific supplier. This is where we're getting it from. And here are the ASTM specs that make sure that it meets, what you want for PVC pipe. So typically submittals are those pieces where the contractor takes a look at the drawings, makes sure, talks to their supplier and gets the actual cut sheet of the actual product that they're going to supply. And it's always fun when you walk onto the site and you say, hey, you submitted this brand of pipe and the other brand of pipe is out here. And they'll go, well, and the contractors will just start saying things. But still, it's like, hey, if you're going to give me submittals and give me paperwork, give me the right stuff. And I went out on a job like that once and I was like, hey, well, I think you guys should take it out. Just kind of like buffing. And you're like, oh, but it's one of those things. It's just, you got to submit the right information. So project types of submittals include all of the following except, so we have to be careful. Product data, we did talk about product data. That's one that typically is included. Shop drawings, what are shop drawings? This is like, you do your structural steel drawings and you have a column grid that's 30 feet between column grid. What's the shop drawing? The shop drawing says, okay, that beam, instead of being 30 feet, we're going to subtract off 6 inches for the column on each side. Then we're going to subtract off a ½ an inch on each side for the angle connection. Then we're going to do a 1/16 for, whatever. But it's going to give that beam, that one beam, down to the exact 1/16 of how it's going to get cut, where every single bolt is. And that's what, that's one example of a shop drawing. That's something the contractor will submit to really identify what specifics they're doing. So yeah, so you got this up there. Installation means and methods. This is the except, right? So this is something that is not approved typically by the engineer, right? So typically they might submit these for information only. This might be for information only, but the engineer does not want to take on the responsibility or the liability of installation means and methods. That is for the contractor, right? So these might be submitted, if I could spell here, for information only. But mill certificates, that's another one that would be approved by an engineer. So mill certificates, that's something like you have rebar. Well, here's the mill that it came out of, and here's the test that shows that it actually is grade 40 or grade 60 or whatever grade that it's going to be. All right, so project submittals, that's what they're for. That's project engineer's role, is to review and approve them. And the language on those submittals is always so squirrely, I should say. It's like for general conformance with the project specifications. Like, approval's kind of a even strong word in this question, but it's like for review, right? So that the engineer reviews it, it makes it work, okay? But typically there's a disclaimer on there saying, we don't check quantities. And I remember there was a submittal on a project where we had an architect and he approved the submittal but didn't check the quantity. So he got different window types and approved them, and basically said, here's one window, here's one window, both the windows look good, great, approved it, liked the windows, and it was good. When the windows showed up, you know what happened? The contractor switched the number of windows that got ordered. So we had 10 more windows than the wrong kind. And the contractor came back to us and said, well, you approved it. And we said, yeah, but you see that stamp on it that says we're not checking quantities. That's your responsibility, Mr. Contractor. You submitted the wrong quantity. Look at the drawings. We're not approving the quantity. We're approving the product. We're saying that product has general conformance with what we specified and will work. So you have to be careful with that. That's something to think about as you get down your project administration role or your project engineer role. Okay, so let's keep going here. Question 7. We'll get to numbers at some point, but let's go. Question 7. Which of the following statements best define what is meant by substantial completion? So we've got the project, we did our submittals, we did our project meetings, they might be every week, every other week, whatever it is, but substantial completion. This is when the project eventually will hopefully get done, right? So what does substantially complete mean? And again, this just gets into some of this stuff, you don't know. Some of this stuff, if you get onto projects, you'll start to see what they look like. But typically at the end of the project, there's going to be this term substantially complete that gets thrown out there. So when you see something like this, just be careful. Just read the questions. So take a step back and try to think about it a little. But when you see substantial and completely, they don't go together. Okay, the project, yeah, it can be used and it's occupied by the owner. If it's substantially complete, it's not completely complete. Does that make sense? So we can cross that one out. This one I do like. So project can be used and occupied by the owner, but there's still a punch list of minor work remaining. What's that punch list? Typically that punch list, it's minor things. So like I just went to my doctor's office recently and they just moved into a new facility. Well, when I got there, they said, hey, this is our first day that we're here. And when I got there, they had like like at their counter, there was like, you could see like hardy board, you know, it wasn't complete. And I knew they were going to put tile in, but the tile wasn't done. Something like that could go on a punch list because it doesn't affect or impact the safety of the occupancy. You know, it's just it's kind of a cosmetic thing that needs to get fixed, but it doesn't prohibit the owner from using that space. So the owner wanted to get into the space, they got in, and then the next time I actually went back to the doctors, they had the tile up and it was all completely finished, right? So that would be kind of like a punch list thing. It's substantially complete. It's a date that signifies the owner can take control of the space and use the space, but there still could be some minor things. So where does this go? Contractors, well, let's just mark that one as right because I like it, but let's talk about these other ones because I think it's worth talking through because some of these other things out there, it's just they're worth talking through. What's a performance bond, right? So what's a performance bond? This is on some jobs what you'll get the contractors are required to, you know, post a bond for the project. So if they don't finish the project, what's going to happen? The contractor's going to call that bond and basically take the money to go finish the project. So what's a contract? A contract is, hey, this is the work that needs to get done and you're on the hook to do it. And if you don't do it, you're giving me a bond that's backed by your assets, like your equipment, your office building, whatever it is, right? The bonding company would then go after those assets if they had to pay out the bond. Normally, you're not going to use a performance bond to finish remaining work unless the contractor is like going default or something, or doesn't finish the project or goes bankrupt. You know, normally you're not going to call a bond when you're at substantial completion. Okay, that's if the contractor fails to perform, and you basically have to kick the contractor off and call their bond in order to go finish it. Okay, and then final release of liens. What's a release of liens out there? A release of liens just says that the subcontractors will say, okay, I have gotten paid, I'm not going to come back after the owner for money, so I'm happy and I'm done. But normally before final payment is released to the contractor, they need to get a release of liens from their subcontractors saying that all the subcontractors have been paid and we're done. Does that make sense? So you don't want a subcontractor coming back and saying like at the you know, 6 months down the road, hey, the contractor never paid us, right? Remember that project delivery where you got the GC, you know, you got the owner, and then you've got to the GC, and then you got the subs. Well, how does the money flow? The money flows from the owner to the GCs, right? Or from the owner to the GC to the subs. But what happens if the GC doesn't pay the sub? The sub can sue the owner. The sub can put a lien on the owner's building and say like, hey, well, I never got paid for the work. I did all this work. I never got paid by the general contractor. So what the owner typically will require is a release of lien saying like, hey, the GC, not only did you get paid, all your subs got paid, everybody's happy, and then they'll release the final payment, right? And maybe that, you know, the release of liens is contingent on a certain amount of what's in the next question here, but retainage, right? So this is the next question. What's retainage? Question 8. A typical amount of retainage on a project is most nearly. So what happens? Well, the contractor's contracted to do work. So they do work, they build a project, and then what happens? Well, then they submit a bill and say, hey, Mr. Owner, I want to get paid. Okay, so they submit a bill, and the owner says, okay, you can get paid. Let's just go verify the work's done. We'll pay you. And let's say they submit a bill for, a bill for $10,000 or $1 million or whatever, right? What's the owner going to pay that contractor? In other words, how much money is the contractor going to get? Do they get $10,000? Do they get none? I mean, like normally you have to pay the contractor, but normally what you do is you take this money and you break it into two parts: the payment and retainage. right? And normally it's split about 95% and 5%. Okay, so normally what happens is the contractor will get what's 95% of 10,000. That's 9,500, right? So 10,000 times 0.95 is going to be like, normally the contractor would get a payment of 9,500. Sorry, let me write correctly again here, but 9,500, and the retainage would be like 500. So you know, this amount over here, the payment that this is to the GC. Right, so this is, you know, to the GC, and what's left is this is, you know, to the GC, and what's the difference? This is kind of like immediately after verification the work's been completed satisfactorily, and the retainage goes, you know, at final payment. This is after the punch list is all done, everybody's happy, and all those little things are 100% complete. Then they get the retainage money. Does that make sense? So this is held, you know, kind of till, this is like till like the end of the project. Sorry, this is held like, you know, final payment. Actually, let me write it this way: at, you know, end of, not that you can see under my head, but end of the project. Does that make sense? So the retainage is there to keep the contractor around long enough to finish the job and to do it in a way that's satisfactory. Normally 5% is enough. Sometimes owners will go to 10%, but 5% is a typical value. You're not retaining 100%. You're not retaining 50% or 1%. Normally 5% is, you know, the 5 to 10% range is what's held for retainage. So we're cooking here. We're already through question 8. Okay, and let's keep going. A couple more what, you know, conceptual questions here, and then we'll start getting into numbers, and hopefully it'll be more fun. But who knows? Maybe this is fun for you. It's fun for me. So let's keep going. OSHA requires trench protection systems be installed for the safety of workers whenever trench is dug, or trench is 5 feet deep or greater, when the work in the trench will exceed 4 hours, or only if the trench is 8 feet deep or 20 feet long or greater. Okay, so which one is it? Well, what is trench protection? Trench protection is what happens when, let's say you have some earth here and you dig a trench, right? So here's your earth, right? And you dig a trench. Well, you know, Johnny and Jane or whoever, they're going down into this trench to work. Well, what's the problem? This trench is not stable and it wants to collapse on Johnny. Okay, and Johnny construction worker doesn't like soil collapsing on him because he likes his life and wants to live. So what's reasonable? Well, is 5 feet okay? I mean, is 8 feet too much? Anytime a trench is dug, well, there is some leeway there, but typically what OSHA is going to require here is a time that is or not a time, but a trench protection that's dependent on the depth. So it's dependent on the depth. So what's going to happen is, in this trench we're going to put a trench box, right, that's going to hold up this trench so that Johnny, or you know, whoever's in that trench is going to be safe. Okay, and that's trench protection. Typically OSHA draws the line at 5 feet. Okay, if it's in stable rock, you can get away with more than 5 feet, but you can be in less than 5 feet if the soils are incredibly unstable as well. Typically there's some judgment by a competent person that has to make that judgment to make sure that it works. But 8 feet, way too much. Trenches, I mean, if you Googled, you know, trench death, you can see people that have died in trenches, and it's not cool. It's not good. It's one of those things that is really taken for granted, and in an instant can kill somebody. So safety is a huge thing. It's why I made the title, you know, the title thumbnail on this screen, or for this video here, yellow, right? I'm wearing red today, just, you know, to make it bright colors to stand out there. I didn't have a chartreuse, you know, like Izod shirt to wear, but maybe I should go grab one. But safety is one of those things that is going to be super important. And it also shows up in this construction operations methods thing. One of the things that I did when I taught a construction admin course is we'd start each and every class with a safety talk. It's one of those things that is important. So remember, when you go to the FE and start sitting down to take the FE, bring a glass of water, keep hydrated. But seriously, stay safe out there. Look for companies that are safe. And if you ever get into a company that's not safe, look for a different company. Safety is, it's great to do a lot of good work, but if at the end of the day, you or someone you're working with doesn't go home, it's probably not a great day, okay? It's something that can be, prevented most of the time. Are there accidents? Sure. But can we do things in a safe way? Yes. And that's one of the things that we want to do and make sure happens. So the next question, basic responsibility, means and methods. I hit this twice in here, but again, the basic responsibility for means and methods is the contractor, right? And that's where you have to be careful. Even in some of your responses as an engineer, sometimes you have to be careful that you don't direct the contractor of how to do things. And that's where you get, you have to be careful on the different jobs. And sometimes DOT jobs versus private jobs, the engineer's role can be different. But a lot of times in private jobs, as the engineer, you have the ability to say that, this work does not meet spec. That's kind of your teeth. It does not meet spec. And you can go to the owner and tell the owner it doesn't meet spec. If it's a safety thing, you can go to the code enforcement official and say it doesn't meet spec. But remember those contract relationships, right? We have the owner, we have the AE or the engineer, and we have the GC. Well, typically, guess what? Typically, there isn't that relationship between the AE and the GC. So you have to be careful when you're on the site, if you're the AE, not to be directing the GC, right? Your role as the AE is to reject the work, to tell the owner it's rejected. If you need to, you go to the code enforcement official. But typically you're not doing it where you're telling the GC what's going on. Now, in some cases, like again, if we look at the DOT, sometimes we have these entities where it's like, okay, the DOT is just one big entity where the architect, the engineer is the owner, and then the site rep has a little bit more authority, right? But typically in a traditional design bid build, process where you're not the DOT, you're not telling the contractor what to do. You have to be really careful, even in terms of, concrete comes back and is a problem. But that's something you have to be worried about. Okay, so means and methods of construction, that's going to be the contractor's responsibility. What about specification? I'm not sure where that comment's going, so maybe you could clarify there, and I'll be happy to talk about that as well. But the specification is, well, I'm trying to think where I could go with this. I think later on in this session, I'll get to a question that talks about specifications. It talks about contract documents. It talks about construction drawings. Well, contract documents are typically made up of specifications, the general conditions of the contract, supplementary conditions, project specification, addenda are, change orders, change directives. So there are a lot of different pieces of a contract, but typically that doesn't take the responsibility of planning means and methods off the contractor. Okay, so let's go to this one, and now we get to some numbers. In fact, don't we write about methods of construction? Oh, okay, so that's the question. Do we write about methods of construction? You can, to a certain degree. So typically, like in a spec, like an earthwork spec, for example, one of the things that I've done is say, well, if you hit blow count material that's 50 or higher, we can consider that rock. And then, your methods of excavation, you can get paid more for, type of thing. Sometimes if you have a really specific, I'm trying to think of if there's a really specific method that you have to worry about. It depends probably a little bit on the contract. Sometimes if you have a certain product and you need it done a certain way, you can. But a lot of times, like even with concrete, we'll design to ACI 318, which is the building code for structural concrete, and I'm trying to, it's the building, code and specification for And then but we'll reference ACI 301 that the contractor needs to follow. So ACI 301. So yeah, we'll reference ACI 301, but still the responsibility kind of goes through that. Government contracts, they do change things, and this is where the construction is really hard to talk about on a general scale, okay? Because there are different pieces, whether it's DOT or building, right, construction, whether it's roadways and bridges or it's building construction. There's a lot of intricacies and a lot of specificities, if that's a word, but there are a lot of pieces where they do, right, with government contracts, especially some of those DOT things, where the owner is the engineer. You can start to specify requirements, but ultimately, again, means and methods is typically on the contractor. I could maybe improve this question. The basic responsibility of planning means and methods of construction is typically that of the contractor. That might make this question a little bit better. But yeah, I mean, you throw out the specifics with government contracts. Sometimes there are specific methods, but a lot of times the methods are really thrown to the contractor because the engineer doesn't want to take on that liability. Does that make sense? It's like, as the engineer, I don't want to take on the liability for what the contractor's doing, and I don't want the contractor to come back to me and say, well, this doesn't work, right? I want to specify what needs to happen. The contractor needs to specify how it's going to happen, how it's going to get built, if that makes sense. So are there cases? I'm sure there are, but in general, and I think this word typically might help. Okay, let's go to the next one here, and thanks for the questions. I mean, this is where I love teaching this class kind of in person, especially with people that have done construction before, because they throw out these, well, what about this? I'm working here and they do this, or what about this? I'm working here and they do this. And each of the, I'm going to try to talk in general terms, like general conditions of the contract, like the basic EJCDC documents or the basic AIA documents. And there are specific contracts that can change things for sure, 100%. But I'm going to try to talk more in generalities here. So let's keep going though, and we'll go to question number 11, where we have a local iron worker productivity rate for placement of reinforcement and reinforced concrete foundation walls is 9 hours per ton. So we get 9 hours per ton. It takes 9 hours to put in a ton of rebar. Okay, a crew consisting of 1 leader. So we got like a super here at $38 an hour, and then 3 apprentice, so we got a journeyman and 3 apprentices here, $25 an hour. The labor burden of 60% is used to install 45 tons of reinforcing. The total labor cost is most nearly. Okay, so this brings up productivity rates. This 9 hours per ton is a productivity rate, right? This is saying it's going to take that long to put in a certain amount of rebar. So this is one way that you're going to estimate your labor if you get into estimating. So the question then goes, well, what's the total, right? What's the total man hours that are needed to do this job, right? What are the total man hours? Well, we're going to have 45 tons of rebar times what? 9 hours per ton. And what's that going to equal? Well, 9 times 45 gives me, what's that? 405 man hours. Okay, so that's the total number of hours. Well, how much is it going to cost? That's the next question, right? And this is where we have to sort of figure this out. Well, let's think about this for a second too. We know it's 405 man hours, but if we have a crew, so 1 crew hour is 4 man hours, right? Because we got the superintendent plus 3 apprentices, so that's 4 man hours per crew hour. Okay, we're gonna say that this is equal to how many crew hours? This is gonna be, well, 405 divided by 4 is gonna be about 101.25 crew hours, right? Okay, crew hours. And now what we need is a crew rate. And sometimes you'll go to references that'll just give you the crew rate, and it'll say I got one superintendent and 3 apprentices or 3 laborers or whatever they get called, and this is where sometimes you'll just be given a crew rate, and sometimes you'll have to figure it out. So I set this problem up so you have to figure it out, right? So what do we get? We get a crew rate of, we've got the super at $38 an hour. Okay, we got the laborers at $25 an hour. That's gonna be times 3. Okay, this is times 1, that's times 3, so we get $38 and we get $75. Okay, so we get a total of, what's 38 plus 75? It's $113. Okay, $113. But is that all it really costs? Well, no, that might be the wage, but what do you get paid in addition to wage if you have a full-time job? You get paid benefits, and that's where this labor burden comes in, right? So this labor burden comes in where typically you take the wage, this is a wage, you multiply it by the labor burden, and that's what you're going to get for the total rate. So times, or actually I should probably say, instead of times, I'm going to say plus the burden here, right? So what's the burden? The burden is going to be that $113 times 60%. Okay, so what's that look like? 113 times 0.6 is going to be about 60, roughly 68. So I'm going to say $67.8. So the total crew cost here is going to equal, 113 plus 67, and I'm going to get like 180, $180.8. And is there contractor overhead and profit put on top of that as well? Yeah, normally that gets accounted for in different places, though. Like it depends on how this is getting bid, but typically you have to look at both the wage, the burden, and then there's other markups that the contractor will put on, whether it's equipment rates or office rates, or there's overhead and profit. Those will get added on as well. So what do we end up with? We end up with 101.25 crew hours times $180.8 dollars per crew hour, and I think that gets us a total of about 18,000. So I got like 18,306. Okay, so that's gonna be our answer up here. All right, so let's keep going and see where we get to. All right, so that's question 11. So question 12, another one of those select all and apply questions. But best management practices, temporary erosion sediment control specifically is called out in construction operations and methods. It's something that it gets done on every site, whether it's well, I shouldn't say every site. On every site that it does any site work. So we have temporary erosion sediment control. This does get called out in the spec, though. So what's a best management practice? A best management practice is one of those practices that get put in to reduce erosion sediment control. Or I'm sorry, they get put in for erosion and sediment control, right? So what we don't want to have happen is to have the rain, the earth get ripped open, the rain come down and wash out all the soil into the wetland. Okay, we want to protect that wetland. So the wetland is actually not a stormwater best management practice. It's actually a stormwater management practice. This is a stormwater management practice. I'm having a hard time spelling tonight, but a stormwater management practice as opposed to a best management practice for erosion sediment control. So there's a slight difference and nuance there in the definition. I'm sure somebody will probably argue with me and say, well, that should be a best management practice, but I consider that a stormwater management practice, just like a stormwater pond isn't there to stop the erosion sediment control. It's there for water quality and quantity requirements. Best management practices are put there for erosion sediment control. And silt fence, that's 100% one of those ones that gets thrown, especially on linear projects. You'll see this as almost like a project boundary in some ways, but it keeps soil from washing out past the silt fence in theory. Check dams, another one of those ones. If you have a linear project, what you're going to do is put this in a swale to kind of create, lessen the velocity of the water, lessen the erosion. So check dams, definitely. Vortex valves. There are such things as hydrodynamic vortex separators, which are stormwater or best management practices, and those hydrodynamic separators spin the water around and then have water come back up and out, and they trap sediment and they trap garbage. But the vortex valve, this is a flow control valve. So this is a flow control valve. It's not specifically a best management practice for erosion and sediment control. So I'm going to X that one as well. And then we're going to come here to mulching, and somebody's going to say, well, isn't mulching what you do in your mom's flower bed? Yes, it is, but it's also when you take 2 tons of straw and put it on per acre and spread it out per acre, and it reduces erosion by like 90%. So if you're doing nothing else and you just throw straw down, you eliminate surface erosion a ton, right? So on flat surface, it doesn't really work. I mean, it does help as well when you have slopes, but specifically on flatter surfaces, mulching is a great idea. It's cheap, it's easy to kind of distribute the mulch, the straw kind of everywhere, and it does a lot of good for protecting and slowing down that runoff, and also eliminating those initial amounts of erosion. And then concrete washout stations. This is also another one of those best management practices, because what we're trying to do with the concrete washout station is we're trying to take whatever's left in the truck, the mixer, and put it into a plastic lined bin. Essentially, a lot of times it's made with straw bales. You put some straw bales around, or hay bales, and you put you line it with plastic, and you dump the excess concrete in there, so you don't get all that highly alkaline waste kind of going right into a stream. What you're trying to do is prevent that. So you're capturing it, letting it the water evaporate, and capturing it. So concrete washout stations are considered something for erosion sediment control. They're typically best management practice. Normally they're for protecting streams, lakes, wetlands, the water bodies. But again, the stormwater wetland, that is a stormwater management practice. They're super good for the environment, super good for habitat and that sort of thing. But they're not so much used for as a best management practice. They're stormwater management practice. All right. So hopefully that makes some sense. Hopefully you agree. If not, you just disagree with me. It's more fun to argue. But let's keep going. Actually, sometimes when you get onto job sites, contractors just like to yell. And it's and I was having this conversation with some of my students the other day. It's saying like, one time I got into a job site and the contractor was just yelling. And I'm not really much of a yeller. But I just started yelling back just because it was like, that's how we communicated. It's like, well, I'll try. Why not? So it didn't really work, but I figured I'd try. So if you want to try it someday, you can. But who knows? Hopefully you can make it work without having to yell, and the contractor won't yell as well. So where do we go next? The construction operations. Again, this question is actually inspired by the NCEES sample questions. NCEES puts out like 10 sample questions, and they have a question that's kind of similar to this. I kind of used theirs a little bit just to kind of get an idea, but this is interesting because if we're looking at productivity, this is another one of those things where we have to look at how many pieces of equipment are we going to put on site to make sure that we're keeping everybody busy and we're keeping productive here. So what we have is an excavator, and we have a 1.5 yard bucket, and it's used to remove soil at a site. Okay, so what do we have? We have an excavator, right? And it's got a big old bucket here, and it's going to dump stuff into a dump truck. Okay, and this is a dump truck with probably too many wheels, but that's okay. We're going to take a whole bunch. If you look at a picture, we're going to take a whole bunch of soil out, and we're going to dump it into these trucks. Okay, so the question is, sorry, I got to make this a little bit better. Okay, the question is, let's keep going with the questions. We got 3 trucks with 12-yard capacity. So we got truck number 1, right? And then lined up behind him is truck number 2 and truck number 3. So we got 3 trucks. They have a 12-yard capacity, so let me just write this, 12 cubic yards. Okay, so this is maybe truck A. And then what do we have? We know that it's going to take a certain amount of time to fill that truck, and then it's going to take some time for that truck to go somewhere else and do what? Dump its load, right? So it's gonna you know, come up here, it's gonna, you know, come over and dump. That's what a dump truck does, it dumps. Okay, so I gotta make that a better pile. Okay, so that's what we're gonna do. So it takes a certain amount of time to fill, so there's a certain amount of time to fill, and what we know is that we can fill at a rate of 2 cubic yards per minute. Okay, so let's stop here. How long does it take to fill 12 yards? Well, if it's 2 cubic yards per minute, what we're going to do is we're going to say, well, we have 12 cubic yards, and we're going to divide by 2 cubic yards per minute, and we're going to get, how long is that going to take? It's going to take 6 minutes. Okay, so 6 minutes to fill a truck. Makes sense? 12 yards, a big bucket. We're gonna fill it. And then what's going to happen? It's going to take some time to dump and return. Right? So what's this? What we're told here is that it's going to take 14 minutes per trip. So this is just an estimate, but 14 minutes per cycle. So that's to go and to come back. It's going to take 14 minutes. So the total cycle here is going to take what? 20 minutes, you know, per cycle. So that works out pretty well, right? But what we have is let's take a look. We got 3 trucks, right? It's going to take 6 minutes to fill the first one. So, you know, from you know, we can look at it like this: from 0 to 6, what are we doing? We're filling the first truck. You know, fill the truck A. Then what happens? Well, from 6 to 12, what are we going to do? We're going to fill truck B. And then, I mean, this is kind of like a timeline, right? So this is kind of like a timeline here. And then what are we going to do next? Well, from 12 to 18 minutes, what's going to happen? We're going to fill truck C. So this is what the excavator is doing. And then in theory, what we'd like to have happen is at 18 minutes, we're just going to fill again. But what's the problem? From 18 minutes to 20 minutes, the excavator is idle, right? He's just waiting for somebody to come back. Okay, they're waiting for the dump truck to come back. And honestly, this is where you have to kind of get to the point of what are we going to do? How are we going to balance this? A 2-minute wait time for an excavator really isn't bad. If it was a 6 or 10 minute wait time, then you'd want to get another truck in there, right? But here we're going to wait, and basically what happens is then the cycle will start over. Then the cycle repeats. Okay, so the idea here is how much with this equipment setup can we do in 1 hour? Well, the most that we can do is, what do we have? We have 12 yards, 12 yards, and 12 yards. But what we have to remember is this is 20 minutes per cycle. So we're going to get a total of 36 yards, you know, per 20 minutes. But then we're going to do what? 60 minutes per hour. So what's that going to be? 36 essentially times 3. 60 over 20 is going to be 3. So 36 times 3 is going to give us the most that we can do with this is going to be 108 cubic yards per hour. So that's going to be our total productivity here, our idealized productivity with this set of equipment. So, you know, if you haven't seen those that set of NCEES sample questions, definitely take a look at them. I think NCEES has them on their website, but take a look at them. It's worth looking at, kind of to see how they're set up. All right. So this is cool. Let's keep going. Question number 14. Activity on node schedule. I love these schedules because they're generally pretty straightforward and hopefully they make some sense. And one of the things you'll notice is that so far I haven't really done anything with the reference handbook. And why is that? That's because there's not a lot in the reference handbook when it comes to construction. So if I come back over here and find my reference handbook, there's 1 page. Okay, so I'm in the reference handbook now. If I go before that, we're in surveying. If I go after that, we're in environmental. So we're on 1 page here, and this is where this 1 page starts to come in. So we have a couple things going on here. We have CPM, precedence relationships, and we talked a little bit about those start dependencies, or finish dependencies, or finish start dependencies. We talked a little bit about that earlier. There are activity on arrow diagrams. Typically the ones that I've used have been activity on node, and that's normally the way that I've seen this. I could see this definitely showing up, and basically, you know, you might be given something like this where it's already set out for you. You might just be given a list with precedence, right, where you have, like, you know, you have task. So for example, you could just be given like a list where you have task, right, and duration, and, you know, predecessor. So you could just be given something like this where, you know, you have task A, there's no predecessor, and the duration 6 days. Okay, task B, the duration is 4 days, and the predecessor is A. So you might be given something like this where you have to go and build your table, as opposed to having it given to you, right? And like task C, again, here we have 3 days, the predecessor is A. So you might have something like that where you have to take this, you know, this table and put it in to a chart like this, right? But this is what we're given. We're given, you know, A through H, a bunch of different tasks, and these values here are the activity duration. So I kind of set this up already so that it kind of matches this, but this is where we have early start, early finish, duration, float, late start, and late finish. So we're gonna go through this schedule. We're gonna try to figure out what the critical path is, and then hopefully if you get a question like this, you can nail it when you get to the FE. So what we're gonna do here is we're gonna say, let me just write that in here just real quick though. So what we have is, you know, task, activity duration, float. Then we have early start, late start, early finish, late finish. So hopefully that makes a little bit of sense, but basically all that we're doing here is we're saying, okay, we have this task A, its duration is 6, but the project's going to start on day 0. Okay, it's going to start on day 0, and then the early finish is going to be 6. Okay, so the earliest that this task can finish is on day 6. Well, what's the earliest task B and task C can start now? The earliest these tasks can start is day 6. Okay, what's the earliest task B can finish? Well, 6 plus 4 is going to be 10. And then we just keep going through this process, right? So I'm just going to keep going here. 6 plus 3 is going to be 9, right? And then what's the earliest task D can start? Well, the earliest it can start is 10. 10 plus 5 is going to be 15. And then I'm going to wait to go to task G, especially because that has 2 coming into it. Let me come here, right? I got 9 for task E and 9 for task F. 9 plus 2 is going to be 11. 9 plus 7 is 16. Okay, let's keep going here. We have 2 activities coming into task G, and these are the ones that you have to be careful with. When you have 2 activities coming in, what's the earliest task G can start? Well, in theory, if all that we were worried about was task E, it could start at day 11, but we're not. Both of these have to finish before you can do task G. So we have to basically take the longer of these 2, and on our forward pass, we take the longer, so we take the 15, not the 11. Does that make sense? 15 plus 4 is going to be 19, and then we're kind of in a similar situation here. We're at task H. We have 2 lines coming in. So what's the earliest we can start task H? We can't start task H until both of these have been completed. So we're gonna start at 19 and finish at 21, and that actually gives us the duration of the critical path. The duration of the critical path is essentially the longest that this project will take through your first pass. I mean, it's defined as where there's 0 float, but then we have to get to float. What's 0 float? Let's take a look and just do the backwards pass as well, because basically what we're going to do next is we're going to go backwards. Well, if this is an early finish, the late finish we're going to start with here is 21. And maybe you have a project where it could go further, but we're going to start with 21, and then we're going to come to 19 here, because 21 minus 2 gives us 19. And what's this other value here? This other value here is going to be our float. And if we come back to our diagrams here, the float is going to be the late start minus the early start, or the late finish minus the early finish. So let's take a look at that and see. Let's see what that looks like. So the float is going to be, for this case, 0. And when we see that, that's going to be part of the critical path. So anything that has a 0 float is going to be part of our critical path. Okay, so when are we going to, what's the latest we can finish this one, still be on track? This is going to be 19. And 19 minus 4 is going to be 15. And again, 0 float. 19 minus 19 is 0. Okay, and then we're just kind of going back through here. But one of the things that we have to look at is what's the late finish is the earliest of the late start successors. So the earliest of the late start successors. All right, what this is saying here is, well, let's keep going backwards. Well, let's come back down to here. We'll say 19. This one could start at, or this one could end at 19 and not delay the project. You see that? 19 minus 7. What's 19 minus 7? I can't think, but I think it's 12. Maybe you can get me right. You can, but yeah, what's the float? 19 minus 16 is going to be 3. So this has some float, and it's not critical, right? This could be shifted 1, 2, 3 days and not impact the schedule. That's what the float means. Okay, and then here the latest that either of these can finish are 15. So 15 minus 5 is going to be 10. 0 float. We're going to put our 10 here. 10 minus 4 is going to be 6. 0 float. And then let's keep going to our other pass here. 15 minus 2 is going to be 13. What's 15 minus 11 is 4 for float. Okay, you see what I'm doing? Hopefully these aren't too crazy and you can get them, whether it's a critical path or whatever you're looking for. But hopefully this makes some sense. The earliest of the late, the earliest of your late starts is going to be 12. Is going to be the earliest of our late start here. And then 12 minus 3 is going to be 9, and 12 minus 9 or 9 minus 6 is going to be 3 days of float. So what's the critical path? Again, the critical path, actually I didn't finish it yet. Let's finish this here. The earliest of these two is going to be 6. 6 minus 6 is 0, and 0 float. So the critical path, we're going to follow that 0. The critical path is going to follow that 0 float. Okay, in other words, we can't move these activities at all and still maintain the same schedule. Okay, so that's going to be our critical path, is going to be this path here, and these activities are going to be on the critical path. And you might be given a conceptual question about this. You might be given, I wouldn't be surprised if you get some network precedence diagram like this that you have to either fill out or complete or do something with. But identifying the critical path looks at which ones have 0 float, can't be moved anyway, and still maintain the same schedule. Okay, but this gets into some of those task durations, predecessors, those types of things as well. All right, hopefully that's not too crazy and makes a little bit of sense. So let's keep going. No questions. You guys are quiet tonight. This one is one of those ones that I threw in there because of the reference handbook. Okay, so this one gets thrown in, and I taught a scheduling class at one point, and we did some basic kind of allocation of resources, that sort of thing. This one I threw in there specifically because there's one page on construction, and half of it is taken up with an earned value analysis. And it's taken up with variances, indices, forecasting. These are equations in the reference handbook, so I threw them in there. So let's do an example of what this looks like. And actually, let me do this too. I'm just going to take all these definitions so we don't have to flip back and forth quite as much tonight, and take a look at it. So I'm just going to bring this over, and let's take a look when we come back to where we are. So I'm just going to paste that in kind of quickly here, and hopefully I can make it work. So it's a little big, but I can make it smaller. And we have our definitions as well. Okay, so let's see what this looks like. Okay, so what we have here is we have a schedule, and this isn't a crazy project. This is kind of like a real simplified Gantt chart that you might see in like a Microsoft project or something like that. And what we have is a land development project. It's scheduled on a weekly basis, so week 1 through week 8. And the budgeted costs incurred, the percent complete after the first 4 weeks is provided in the table. So what we have is we have essentially a stopping point, like right here at week 4. And why week 4? Because typically contractors, they don't just do work because they like you, they do work because they want to make money. And they typically pay on, normally it's a monthly basis, it's a monthly pay rec. Okay, so what happens is we have costs associated with each of these tasks. We have a budgeted cost, an incurred cost, and how far complete each of these tasks is. So for example, task 1 is 100% complete, and let me shade that in. So this is 100% complete. It's good. We're happy. Okay, the budgeted cost is the same as the actual incurred cost. So they budgeted 2,000 what was spent to mobilize to the site. Erosion sediment controls, we budgeted 4,000, but it cost 5,000. We had a big rainstorm, we had to go fix things, and it cost us 5,000. Okay, but it's 100% complete. We got everything in place, and we're happy. And I almost made the schedule more complicated with erosion and sediment control maintenance in there, but I wanted to try to pare it down a little bit. So I just left that as it was. Okay, let's say it took a little bit of extra money to get them in. Okay, what's next? Tree removal. Again, we're at a budgeted cost. 22,000. The incurred cost was actually a little bit less. So, trees got out of there quickly, a little bit more quickly. We had a couple guys come along and say, hey, can I have some of those trees? I want to burn them for firewood. We sold them, whatever. But let's say the incurred cost was a little bit less. We're still at 100%. We got everything done in the time frame we wanted. Okay, let's keep coming down here. Clearing, we budgeted 18,000, incurred 15. This is 75% done. This is a little awkward because we have 3 blocks. So what does that mean? We're actually 75% done. So even though we're only at 4 weeks, we can kind of go a little bit further because we're at the 75% mark, right? This is kind of like the 75% mark. Does that make sense? So we're a little bit kind of ahead of schedule there. And then let's go to this next one. The grading, though, we're only at 50%. So if we're looking at the 50% line, where's 50%? Here's 50%. Okay, so I'm taking a long time kind of to set this project or problem up, but what you'll see here is we're actually a little bit behind schedule here. So we're ahead on one part, a little bit behind on the other. Maybe we had a piece of equipment breakdown or something. I don't know, but or the guy got sick. So maybe he had COVID. Who knows? But let's say we're a little bit behind on that one. Okay, but cost is right on. We're about half of the budgeted cost, so we're pretty happy there. We haven't done anything for stabilization yet. We haven't done anything for demob yet. So the question is, at the end of the first 4 weeks, that's kind of just the whole project, the problem set up, and I apologize for kind of taking a long time. I just wanted you to kind of figure out where that was. The question though is the project over budget, and is it on budget, on schedule? Those are the 2 things that always want to be asked and known. Is it on budget, on schedule, right? So how do we figure that out? And this is where we kind of do an earned value analysis. And basically what we're going to do is we're eventually going to get down here. We're going to calculate the CPI and the SPI. This is the cost performance index, the schedule performance index. These will tell us whether we're on budget or over budget, whether we're on schedule or behind schedule. So to do that, we have to go and calculate each of these pieces: the VCWS, ACWP, VCWP, the cost variance, and the schedule variance. So what I'm going to do here, and hopefully I have enough room, is I'm going to make another table, and that table is going to I'm going to start with my activity. Okay, and then I'm going to calculate my BCWP, or budgeted cost of work performed. I'm going to start with the work performed. The reason I'm starting with my work performed is because that's the first one in each of these, each of the cost variance and the schedule variance. I'm going to start there, and then I'm going to do the actual cost of work performed, and then I'm going to do the cost variance first. And then I'm going to do the budgeted cost of work scheduled and the schedule variance. Okay, so these are all different pieces that show up in this earned value analysis. So rather than write down all the activities, I'm just going to label these. I'm going to label this kind of like 1, 2, 3, 4, 5, 6, 7. So just to make it a little bit quicker here, I'm gonna just copy those down. So 1, 2, 3, 4, 5, 6, 7. So those are activities. And let's start with the actual cost of the work performed, because that's what's given to us here. We're given this incurred cost. This is the actual work of the cost performed, right? So this is the incurred cost, and I'm going to put that down. So the actual cost of the work performed, I'm just going to copy that down here. I'm going to say we have $2,000, we've got $5,000, we've got $20,000, $15,000, $22,000, 0 and 0. So this is essentially our incurred cost, right? That's our incurred cost. This is our ACWP. Okay. So now you're thinking, well, what we got is the budgeted cost, right? So the budgeted cost, we should just be able to just write that down, right? Kinda, sorta. So this is where you got to be a little bit careful. The budgeted cost is the budgeted cost of the work that was actually performed. So since we have 100% of the work complete here, the budgeted cost was $2,000. Since we have 100% of the work complete here, the budgeted cost is $4,000. Since we have 100% here, the $22,000. And now this is where we get, because we only have 75% of the work complete, or actually we have more than we budgeted, 75%, so 0.75 times 18,000 is going to be 13,500. So this is going to be 13,500. Okay, so that's the budgeted work of 75% of the work that was completed. Does that make sense? So question, or the next one, 50% of 44,000 is going to be $22,000. 0 and 0 come for 6 and 7 because there's 0 work complete, and that's good. Does that make a little bit of sense? So we're taking that, we're figuring it out. And what we can see here is if we find the cost variance, we kind of go through here, and some of these are going to be positive, some of them are going to be negative. We could also just add all these up, okay? And if we add them up, I think I got like 63,500 and 64,000. So what does that mean? That means our cost variance, right? What's our cost variance? Our cost variance here is going to be the BCWP minus the ACWP, and what we're going to get here is minus 500. So what's the variance? We're $500 over budget. The actual cost of the work was $500 more than what we budgeted. Does that make sense? So that means we're going to be over budget for this one. This is going to be over budget. So we know it's going to be over budget, and now we have to figure out the schedule. The other thing that you could look at, and the other kind of question that might get brought up here, is what's the CPI? The CPI is going to be the budgeted cost of the work performed divided by the actual cost of the work performed. And what do we get here? 63,500 divided by 64,000, and this is going to be equal to like about 0.99. So what does that mean? It's less than 1. Less than 1 means it's over budget. Less than 1 over budget. So it's only like 1% over budget. Not a huge deal, but it's a little bit over budget. Okay. So let's do the same thing with schedule performance index, and what's that going to look like? The BCWS, what do we have? We're going with this is going to be the budgeted cost of the work scheduled, right? So the scheduled work at this point, we anticipated that all of this work would be done, so the budgeted work of that cost was going to be 2,000. We expected this one to be 100% done, so the budgeted work of that one should have been 4,000. This task was supposed to be 100%. The budgeted cost was 22,000. This one was only supposed to be 2/3 done. We're at 75, so we're ahead of schedule. But what do we notice? We notice that 2 over 3 times 18,000 is going to be 12,000. So the budgeted cost of the work schedule, we're only supposed to have 12,000 done, but we have 13,500 done. 13,500 worth of work done. It's actually 15, so it's over budget. But we have more work done than we had previously scheduled. And then kind of this one here, we're at 50% of the work. Did I draw that wrong? I did. I was thinking this was 4. Maybe I was, sorry. I wasn't thinking that was right. Nobody caught me on that one. So let's come back here. We're actually at 50% of the work complete. So look at that. We're at 50% of the work complete. That's where we're supposed to be. I was thinking this one was the 3 bars as well. We still have 50% remaining. Okay. I apologize for that, and Nobody caught that earlier. You gotta give me those comments, okay? But the good news is we fixed it before we went home for the night. So the cool thing is I did find it here. Look at this, because the budgeted cost of work scheduled, we're supposed to be halfway done at the end of 4 weeks. We are halfway done. That's good. So the budgeted cost is half of that cost, which is going to be $22,000. Okay, we can add all these up. We got zeros for the last two because we didn't budget any of that work yet. We add all this up, and I think I got like 62,000 if I add all that up. Okay, so what's the schedule? The schedule variance. The schedule variance is going to be the BCWP minus the BCWS. So what's that? It's a 63.5 minus 62,000, which is going to be what, 1,500? Okay, so what that means is we get a positive value here. In other words, that means we're actually ahead of the schedule, because what do we have? We have this SPI equals the BCWP over BCWS. Sorry. And what we're going to get is, what's that? The BCWP is 63.5 divided by 62,000. And that's going to be about like 1.02, maybe 1.024. This is greater than 1. Therefore, we're ahead of the schedule. Okay. So we are ahead of schedule here. So so C is going to be the answer. A is not, B is not, and D is not. Okay, so hopefully that makes a little bit of sense, and we'll keep going. So the other thing you might see on this are cost curves. A lot of times, like cost curves, you're going to have like an S curve here where you're at 100% up here. It might take some time to start getting into the project. And then, as you really ramp up production, you'll gain a lot of your costs. And what you're looking at is where's the, if we get to this point of like 4 weeks here, 4 weeks, right? And this is the budgeted cost of work performed, right? What we'd see here is the actual cost of work performed would be a little bit higher. So this is the actual cost of work performed. Right, actual cost of work performed. In this difference here, that's your cost variance. Okay, so that something like this could show up too, where you see some of these cost curves versus the schedule. The schedule down here, this is the BCWS, or the budgeted cost of the work scheduled. And this is a little bit lower, right? So this is like the the budget cost of work scheduled was 62, 63.5, and 64. So you might see these cost curves. You can kind of track where you're at with those curves as well. All right. Next week we're on to surveying. So hopefully that helps. Surveying's all sorts of fun. It's more fun when you're in the field and setting levels up and total stations and that sort of thing. But we'll get on to surveying next week. So let's keep going. We got a few more questions here. Hopefully they're pretty basic, pretty straightforward. And we've got some good jokes tonight too, and we'll go for it. Maybe they're not good, but at least I think they are. Consider the foundation plan in section below. The total volume of concrete required to construct this foundation, do not include waste, in cubic yards is most nearly. So this kind of gets into that interpretation of contract drawings. It also gets into just basic estimating, right? What's estimating? Typically it's finding volumes or finding, like the areas or something along those lines. In this one isn't a super crazy thing. It's a, it's a small building, relatively 30 by 40. It's got a 4-foot concrete wall with a 1 foot by 2 foot footing, a 4-inch slab on grade. Nothing too crazy. There's a whole bunch of information in here about rebar, and we could go crazy with reinforcing estimates and that sort of thing, but we're not going to tonight. All we're doing is estimating concrete. So to estimate the concrete, all that we're going to do is we are going to estimate the various pieces here, and hopefully that'll make some sense. So we're going to estimate some pieces and try to figure out how much this is all going to cost. But before we even estimate that, what I'm going to do here is I'm going to look at this dimension from the center to the center of this wall. So what I want to do is, because this is like the center line of that wall, I want to get that dimension, you know, from the center line to the center line. And what we see is it's going to be 30 feet minus, you know, we have the 1 foot wall thickness, so minus a half foot on one side, minus a half foot on the other side. It's going to be 29 feet. And similarly down here, what we're going to do is we're going to subtract these off and get to 39 feet. Okay, make a little bit of sense. But the reason I want to do that is because I want the perimeter here. The perimeter is going to equal what? 29 feet times 2 plus 39 feet times 2. And that's going to equal, I got like 130, man, I'm writing things backwards too, but 136 feet all the way around the perimeter of this thing. And the reason that I want that is because what I want to do next is I want to find the volume of like the wall footing, right? So I'm just going to take each piece here, but I want the volume of this wall footing, right? So this is the wall footing. I want that volume. And to get that, all I'm going to do is I'm going to take the 1 foot times 2 feet, right? That's the total area of that. And then I'm going to multiply it by the 136, which is the perimeter. So when I do that, I get 272 square feet, okay? Which is equal to, you know, how do you go from cubic yards to cubic feet? 27, you know, cubic feet equals 1 cubic yard, okay? And if I actually wrote cubic feet, that would be better. But I divide this 27.2 by 272 divided by 27 gives me like 10.1 roughly, 10.1. And sometimes I use CY for cubic yards, sometimes I use yards cubed. Either way, it works. The next piece that we're going to do here is we're going to do the wall, the volume of the wall. And what's that going to be? Well, that's going to be this piece here, right? So this is the wall. And what are we doing? We're just taking 1 foot wide by 4 feet thick times, again, that perimeter. That's why I wanted to start with that perimeter, because that perimeter is super important. And if it's basically going to double our 272 or get us to 544 cubic feet, or in this case, it's going to be 20.2 cubic yards. What else do we have left? We have the slab. So let's take a look at this slab here, right? So we have got a slab. Volume of the slab is equal to, well, this is where we have to get the area of the slab, and we haven't calculated the area of the slab yet, but the area of the slab is going to be, well, it's going to be 40 feet minus 2 feet, because we have to come in 1 foot for each wall, right? Times 30 feet minus 2 feet. And then times the thickness of the slab, so 4 inches divided by 12 inches per foot. And that'll give us, I think it gives me like 355 cubic feet, which is going to equal about 13.1 cubic yards. And somebody might want to just add all those up, but don't forget, take a look at your plan, because this plan also has some square footings, maybe for some like pipe columns, or I don't know what they're for, but let's say that there's some columns in here, right? So if those are in there, we have to worry about them as well. And those are going to be the volume of the spread footings, right? And what's that going to be? That's going to be 4 feet times 4 feet times 1 feet, or 1 foot, because we're told they're 4 by 4 by 1. And then we're going to multiply it times the 3, 3 each, and that's going to give us what, 16 times 3, so 4 times 4 times 1 times 3 is going to be 48 cubic feet, which is going to be about 1.8 cubic yards. And now if we add all this up, I got about 45.1 cubic yards, which is going to get us most nearly 45 cubic yards. And yeah, there might be waste that gets thrown in there. You might have to include some additional for, waste or whatever, or if you're doing trucks or loads, you'd have to break it up separately as well. But this kind of gives us the total concrete estimate, and you have to interpret these drawings, understand what you're looking at, and how to make them work to get your estimate. All right, so let's go to one more estimating question, then we'll end on a couple of conceptual questions, and we'll go from there. So The steel framing plan below, total weight of steel required for the girders and beams in tons is most of the time steel gets estimated in tons, so we're going to start there. And basically all that I'm going to do here is I'm just going to make a list. I'm going to make a list of each beam. I'm going to make a list of the weight. I'm going to make a list of the length. And what else? The quantity. And the total, you know, this should be weight. Let me write this a little bit better. This is the weight in pounds per foot, right? And this is the weight, the total weight, okay? That's the total pounds. So I'm just gonna look at each of these beams in turn. So W18 by 35, that's 35 pounds per foot, right? We know that this 35 is the weight per foot of the beam. The length, I'm just gonna use this 18 here. Technically it's a little bit smaller because it gets brought in for that column. How many of them are there? There are one on this side and another one on this side, so there's two, a quantity of 2. So our total weight is going to be 35. 35 times 18 times 2 is going to be 1260. So 1260 pounds. What's next? I'm just going to do the same thing. March right down 21 by 44. That's 44 pounds per foot. That's still 18 feet. One beam, and that gets me to like 792 pounds. And then we got these W16 by 36s. Those weigh 36 pounds per foot. Those are roughly 25 feet long. And then how many of them do we have? And what in the world does DO mean? So we know we have 1, 2, 3, 4, and DO does not mean dissolved oxygen. It's a nomenclature that gets thrown on structural steel drawings that means ditto. Or in other words, repeat of what was above or below. So this is going to be ditto. So basically what that means is we're going to have 8 beams, and if we do all that out, I think I got like 7,200 pounds. We add all that up, I got like 9,252 pounds. And we know that some of these conversions, if you know them, it's going to save you some time. But 1 ton equals what? 2,000 pounds. Okay. So what we're going to do is we're just going to multiply, do a conversion here, times 1 ton per 2,000 pounds. And we're going to get about 4.6 tons. So that's pretty cool. I mean, who knew you could estimate steel, even if you didn't take a steel design course, you can still estimate steel. And maybe there'll be a question that's this simple. I don't know. I hope it is. But there are some concepts in here. You have to know that number on the beam, what it means, right? You have to know how to kind of read the drawings, what that DO might mean, you know, different things like that. But as you get into drawings, it should make some sense, hopefully. All right, so let's keep going here, and just a couple questions left. But you know, if there's a conflict or discrepancy in the construction drawings, we're getting into interpretation of drawings here. We did a little bit of that with the last 2 questions, but if there's a conflict, typically you're going to take the most specific one. So what are contract documents made up of? So contract documents are typically made up of what? You have the general conditions of the contract, general conditions. Typically you're going to modify those general conditions with supplementary conditions. So the general conditions would be like the EJCDC document, right? That has the major conditions that everybody kind of has agreed to, their standard. The supplementary ones are maybe project specific or agency specific. You're going to have project drawings, so construction drawings. You're going to have construction specifications. You're going to have project addenda. So if something happens and you know that you want to change a drawing, you're gonna change it through an addendum. You're going to have maybe change orders, or you know, field directives. You know, directives. So depending on what they're called, and sometimes the terminology can be different. But you have all these different pieces that typically form the contract. So which one happens to be or to control? If there's a conflict or discrepancy, and you might think, well, my drawings will never have a conflict or discrepancy, and then you realize you made a drawing, you may have a conflict. Okay. Typically what we're going to do is we're going to take the one that's the most specific and use that one. or in some ways the most recent, but typically in this case, the project addenda are going to be addressing a very specific item. They're coming kind of after everything's been done and put together, but typically that's going to be the one that controls. The general conditions. Hopefully they have an order of precedence and say and specifically spell it out. And this is where different contracts can have different orders of precedence, but hopefully if they get spelled out in the project addenda, most likely will be given the priority. So that's the typically, again, and that's where sometimes this wording in here isn't perfect, but I'm trying to get the typically because some of these concept questions, they do vary between agencies. Okay, let's keep going. Interpretation of engineering drawings. The authority to make design changes to signed and sealed construction drawings can legally be exercised by which of the following persons? And this is kind of title, maybe title is better, but check all that apply. Again, this is one of those questions where you have to check multiple items. So who can make changes to drawings? The same people that put their stamp on those drawings. So whether it's a PE or an AIA, those are the only two people with their stamps that can make the changes to these drawings. So anybody else, if the owner wants to, they shouldn't be able to legally change your drawings. The inspector should not be able to change your drawings. The contractor should not be able to change your drawings. The code enforcement official should not be able to change your drawings, because your drawings are your drawings, right? It's your stamp, your drawing, you're the engineer, or in some, maybe you're probably not taking the FE because you want to be an architect, but these are the only people that are allowed to change those drawings. Okay, and last question here, question 20. A detail is drawn at a scale of 3/4 of an inch equals 1 foot. So what we know here is the detail has, right, so we got 3/4 of an inch, and the real life is going to be 1 foot 0 inches. Okay, so that's what we have. We have an area that measures 3 5/8 by 2 inches on paper. So let me just draw that in. So this is on paper, we've got 2 inches by 3 5/8 of an inch on paper. Right, so we have some area here. So we have some area on the plan, or on the detail, whatever. The area enclosed by these dimensions in square feet, in real life, what is that most nearly? So this is just gets into some basics of drawings, but do you know how to deal with scales? Okay, so in real life, what you have to just be careful with here is to say, well, what is this dimension in real life? So in order to go there, we know for every 3/4 of an inch, we have 1 foot. So this would be 3/4. 3/4 gets me 1.5 inches. Ah, man, I don't really get there. How do I do this? So what I would do is I'd say I take your 2 and divide it by 0.75. If you do that, 2 divided by 0.75, that's going to give me 2.67 feet. Does that make a little bit of sense? When would a drawing need a PE stamp versus an architectural stamp? That's a great question. I'll come back to that in just a minute. I'm going to finish this question and I'll answer that question. So there is a lag going on here. But let's finish this question. But thank you for the question. I will come right back to it. So as we keep going here, we'll go to 3.625 divided by 0.75, and I got like 4.83 feet. So when you multiply those two together, you get this area of 2.67 feet times 4.83 feet, and you get, I think that works out to be 12.9. Okay. So just be careful with your unit conversions here, because it's easy to do something like this. It's easy to do like 2 times 3.625 divided by 0.75, because that's the scale, and that's wrong. Why is it wrong? Because you didn't convert both of them, you just converted one of them. So be careful if you're ever doing stuff like this, to make sure you get that scale right, and just do some basic sanity checks. Does this make a little bit of sense, right? So if I know I've got 3/4 of an inch, does it make a little bit of sense? And make sure you get your units right. Okay. So the question is, when do you need an engineer stamp versus an architect stamp? Typically, architecture deals with the first set of chapters of the building code, with occupancy, egress, and fire safety. Those are the big pieces of the architectural. It's you want to make sure the building occupancy is specified correctly, egress so people can get out in the event of a fire, and fire safety really. So you got the right doors, hallways, corridors, stairwells, fire protection systems. You got firewalls where there need to be firewalls. You have building separation, building maximums, that sort of thing. But the engineers are typically designing the structure and making sure the structure is safe. That's the civil or structural engineers. Then you'll have mechanical doing the HVAC design and that sort of stuff. So there's different types of PEs. There's different types of engineers that will stamp the drawings. So a lot of information here. I wish I could teach you more, but before we go, one of the things that I like to do is just to make it a little bit of fun here. So before we go, all I'm going to do is I'm going to tell you, it'll be a good project when. So let's go there. So it'll be a good project when, and these are actually real things that happen to me on real projects. So if this makes you feel a little bit better because you've experienced stuff like this, then good. So it'll be a good project when you get the bids back and you're a little bitter. But the problem is you're the engineer, right? So your estimate was not a good estimate. Your estimate was too low, and all the contractors said, by the way, your estimate's not good, and this project is going to cost more. And then the owner comes back and says, but the project's going to cost more. Shoot, okay. Yeah, well, it's going to be a good project when you walk into the job trailer and hear, I paused there because I don't like to swear on YouTube or in general, but who the bleep is the engineer? I literally walked into the job trailer on the first day of a job, and I hear the superintendent shouting this, and I'm thinking like, hey, that's me, by the way. So I actually went and said, hey, I'm the engineer. What's going on? How can I help you? With a big smile on my face. And the guy looked at me. He's like, well, this benchmark, it's off. I said, well, that's great. The engineer, by the way, didn't do the survey. We hired a surveyor. He did the survey. So let's go look at the survey. Let's call the surveyor. But before you start saying this about me, let's get some things straight. One, I'm not the surveyor, and two, I'm the engineer, and I'm not. I don't need to be called that. So we had a great relationship. That was the same guy that almost dropped a skid steer bucket on me. I was down in a trench, and I was looking at something with one of his laborers. He came over to dump some stone into the trench, and he was like 10 feet away, but the bucket wasn't hooked down to the skid steer, right, and it fell into the trench, and everybody sort of looked at each other and we're like, safety first, and we all got out of the trench and he fixed it, but good grief, that's a near miss, but glad I still have all my fingers and toes. Okay, it'll be a good project when you get an RFI from the excavator and he's asking what to do since the soil's radioactive. True story. We're doing a roadway project, and we get the contractor saying, "Hey, by the way, we did some Geiger meter readers, and this roadway is radioactive." Well, he had done work in the neighboring part, and he knew that from a different spot that some bad fill was used in this location. So what do? He stopped the project. You figure out how do you get rid of radioactive material? So you call up your subconsultant and figure it out. Okay, it'll be a good project when you Google search the low bidder, and you gotta love Google results. The word mafia shows up in the suggested results. It was a great project. What do you do? Since then the word mafia no longer shows up, but it did when we started. So the word mafia showed up. Oh, great. And it'll be a good project when a supplier requests a substitution. And actually, I called this guy. He wanted a substitution. I called him. I said, hey, what's going on? What do you want to do? And I actually liked the product. I liked the product that he wanted to submit. But the problem was the guy started yelling at me. I was like, I'm just asking you questions here, buddy. Listen, I want to improve your product. I like it. It's a good product. Don't worry. It's a public job. I want to make sure that we check the boxes and we get approved applier to install it, that sort of thing. So I'm okay with substitution. But he just started yelling at me. He's like, "Oh, a bunch of monkeys could put this in. You don't need to be approved." I was like, "Okay, whatever." And I we hung up. And I emailed my project administrator and I said, hey, project admin, guess what? I just had this conversation. Just want to let you know. And he sent me. I actually left him a voicemail. He sent me a one-line email. The one-line email was, you know what it was? It was a link to the local that local city's organized crime mafia webpage, essentially Wikipedia page. It was the Wikipedia page, and the supplier's name was the same as the mafia boss from that city. So you know it's gonna be a good project when the supplier's rep is listed as the local mafia boss. I mean, what could go wrong? But you know, if that wasn't good enough, I still have a joke here. And if you ever need something, take your hard hat off and listen, because you might hear the OSHA. Get it? OSHA. Oh man, what can you do? Just forget about it. Yeah, I mean, what can you do? That's it for tonight. Hopefully the mafia stories were better than the really bad puns and jokes, but that's it for tonight. So thanks guys for joining in. Thanks for the questions, the comments. I appreciate your feedback, because it helps keep me sane and keeps me honest here. So that should be good. And next week we'll hit surveying. We got a couple more sessions here. We'll round out the semester. And I look forward to it. Thanks for joining in. And until next time, keep working hard and moving onward and upward.